Hello everyone, this is Sonali. So today is our day 8. Welcome all of you. So let's start the session. Welcome Manoj, Sandeep, Naresh, Rupa.
Yeah, thanks.
So yes Manoj, you can start now.
Yeah, we can go there. Yeah, let's discuss our scenario-based question. First one question I will go with Naresh. Okay, hi Naresh.
Hi.
Our scenario is like this. We having a platform of e-commerce, and we are bringing the flash sale, and we know that there is a unpredictable traffic is coming to hit us. So how you will manage that using auto scaling group and auto scaling policies?
Okay. Actually, auto scaling, uh, we can, it depends on capacity based on load. To handle unpredictable spikes, we use combination of scaling strategies like baseline capacity, dynamic scaling, and target tracking scaling. Like this, we can use. Coming to baseline capacity, we can keep minimum number of instances running so that your site never down. For
Hmm.
example, if we take minimum capacity uh, for EC2 instances, if the spike increases, then it will increases to 10
Hmm.
EC2 instances. Like this, we can uh, configure baseline capacity with minimum instances. Coming to
Hmm.
dynamic scaling, like scale in or scale out based on metrics like CPU utilization or
Yes.
request count per target or memory usage, we can use. Like, for example, if CPU memory is greater than 70%, for 2 minutes, we have to add two instances. If it is less than 30%, for 5 minutes, we have to remove EC2 instances. Like that, based on capacity of CPU utilization and memory usage, we can configure dynamic scaling. Coming to target tracking scaling, like for most common for flash sales, we can define a target metric and let auto scaling adjust automatically. For
Hmm.
example, our CPU utilization is 50%. It is going beyond 50%. Auto scaling adds instances. If the traffic drops below the 50%, auto scaling remove the instances. And scheduling scaling means if we know the for example, if we have some business at 6 p.m. Spike is increases, we know, we are predicting.
Hmm.
If we know that thing,
Yes.
before that we are scheduling.
Hmm.
That means that we are saying scheduled scaling. We
Yes.
can pre-scale in advance.
Hmm.
It avoids sudden delays when auto scaling reacts too late.
Hmm.
Like this, we can configure auto scaling for flash sales. Or
Yeah, very well covered, Naresh, as this scenario while you were describing. Just I will recall those scenarios which you mentioned here. As you mentioned, you we need to make this is layered auto scaling. That is very good approach we are going, because with only with one feature of auto scaling, we can't handle that much unpredictable traffic. Basically, if we use dynamic auto scaling, that will do the auto scaling, but it requires some time. Okay, means if our sales start midnight 12, then if we are this dynamic auto scaling will start doing the auto scaling after 12 only, when traffic hit our DNS and our domain servers. Okay, so if we use as your approach like a layered auto scaling, so we are using two or more, like scheduled auto scaling, and also like what we can say, predictive auto scaling. You mentioned this predictive nowadays we are using, because this is AI and ML, means it is using like our previous historical data, and it is configuring. That is also one good feature. And another one thing, most of the people are knowing that how it is going in the auto scaling, but internally how it doing auto scaling, it is not clear that much. Okay, means pre-warmed things, right, in auto scaling. So this pre-warmed means whenever auto scaling you mentioned, we need to check metrics like CPU utilization, memory, and count of ALB, like that things. Based on those things, our auto scaling group triggers a event like scale out. So what it will do, it will initialize the VMs or resources. Okay, during that period, initialization period, like a 2 to 5 minute, it will not consider the metrics. Means even metrics is saying more than 70%, it will not read because it is already scaling out. Okay, if it is not, if it is reading every single second, then when until that CPU things is there, right? It needs to reduce till that time it will start creating new VMs itself. Then it will do the over provisioning. So we are configuring this some feature like warm pool, those things, timeout, time in session. Okay, means whenever need to like pre-warm is initialized and suddenly our traffic is goes down. So in that time, our pre-warmed VM first it will reduce. Then our actual VM will come to reduce. This is the internal architecture. It is happening. So if like this, we need to understand how it is working in back end. Those things. Most people is not getting this point. So that I just want to bring in this call. Yeah.
Okay, thank you.
Yeah.
Yes, very well explained by Naresh and Manoj.
Yes.
Thank you. We will go ahead with the next question. I will ask this question to Rupa. Yes, Rupa. Are you ready?
Yes. Yeah, yes, Sonali.
Okay, great. So, suppose you want to your auto-scaling group launch a new instances that is pre-warm before the traffic spike at 9 p.m. So that is traffic spike is happening every night 9 p.m. So which you already know. So which scaling approach you are going to use?
Okay, according to me, the right approach here is to use the schedule scaling, as we already know that the traffic spike will be higher at 9 p.m. So we would use scheduled scaling here with the auto scaling group. So basically, we can scale the desired capacity to 20 instances, more number of instances at 8:45 p.m., which is 15 minutes before daily, and we can also scale down to 2 or 3 or 5 number of instances during the midnight time, because at that time the traffic spike will be less. And then, as Manoj explained in the previous scenario, we can configure the warm pool instances. That means that is pre-initializing those instances with our AMIs and with the user data. So we can keep them at the stop state initially, so that they can boot exactly at 15 minutes before the traffic spike. And also we can make use of some of our monitoring tools such as CloudWatch to track the matrices like CPU utilization and ALB request counts, and also the latency between the instances to the different services, to validate that the pre-warmed capacities are sufficient enough to keep, and also adjust the schedule or instances count based on these traffic monitoring records or the trends. So yeah, this is pretty much.
Okay, perfectly fine. So this is the thing we have to keep in our mind for this scenario. So already we are aware about traffic is going to spike on 9 p.m. So we will make sure we are going to use scheduled type only, and so there is a pre-warmed time. We are going to initialize some of the instances depending on the whatever traffic we are getting. Okay, and that thing we have to do previous only. So all the things we are going to schedule. So we know already 9 p.m. is that is the fixed routine. So we are going to use scheduled time. Yeah, that is perfectly fine. We will move ahead with the next question. Yes, Manoj?
Yeah. This question I'm going with Sandeep. Yes, and let's discuss this scenario for our everyone understanding. So we have the auto scaling group. Okay, it is keep launching and terminating instance rapidly. Okay, you know what is rapidly? It is in launching and terminating. Okay, but and also what the cooldown means cooldown also is not happening. Okay, like it is suddenly it is happening, increasing, decreasing, increasing, decreasing. This is happening. How you will adjust this issue, and how you what approach you will go, and how you will recommend that to the client or organization or anyone, so that this issue will not happen in future or in production environments.
Yes.
Hmm.
So in our scenario,
Hmm.
in auto scaling, the instances are rapidly increasing or decreasing. So usually it happens when the scaling threshold is too aggressive. For example, if CPU is greater than 50% scale out and less than 40% scaling. So here
Hmm.
is cooldown period is very short. So that's
Yes.
why ASG keeps reacting on these temporary
Hmm.
spikes. So what will be solution here there? So we increase the cooldown period. So default cooldown is 300 seconds, which will be 5 minutes in uh, 5 minutes. So here we scale out the cooldown time. So keep it short. For example, if you keep as 200 seconds, so
Hmm.
it reacts quickly to the spikes, and then change the scaling cooldown period. So it increased to the max to 600 seconds. So it avoids terminating the instances too soon. So in scale up.
Hmm.
So in this way, we increase the cooldown period. So next will be we will adjust the threshold.
Hmm.
So if CPU is threshold is too aggressive to say 50%. So if I increase to the 70 or 75% scale out, and for 40 to 45% to scale in. So this like that we can adjust the um, cool down period. So or we can use the step scaling.
Hmm.
So if CPU is uh, reach to max 70%, then we can add one instance or two instance immediately. Or CPU is reach to the 85%, so we can add max 4 or 5 instance immediately. So
Hmm.
like this, we can adjust this scenario. So like that, we use target tracking uh, policy for this. For example, keep the average threshold to the 60%,
No.
and then auto scaling automatically adjust the capacity based on this. So like that, we can use this scaling policy and adjust the cooling period. So like that, we
Yeah.
can handle.
Very well covered in this scenario, and you hit all the points, and you don't give any point to explain me also to add my point. Like that you covered, as you told that things like making wider of our range, threshold range. That is very best approach in this scenario, like keeping the higher threshold and lower those things. That very good point to fix this issue. And also you mention many auto scaling types like step in and other auto scaling. That is also one good idea here to implement. Yeah, we can go with next question, Sonali.
Yes, absolutely.
Yeah.
So the next question I will ask to Naresh. Okay, Naresh?
Yeah. Yeah.
Okay, great. So suppose you are having two EC2 instances, okay, in our web server. So for that you have configured application load balancer.
Okay.
But the scenario happening is your traffic is going to only one instance, not two. Means your traffic is not equally dividing. So that is the work of load balancer, but that is not happening. Load balancer is not doing correctly here that work. So for this how you are going to troubleshoot this, means the both EC2 instances is working or not working, or if there is any other problem like that, how you are going to troubleshoot? Can you explain?
Yeah. Yeah. First, we have to check our load balancer configuration. Like in EC2, we have to check the target groups. Uh, is both EC2 instances are registered as targets or not, and we have to ensure the both instances are healthy state or not, and we have to check the load balancer algorithm like ALBs round robin algorithm, like each request goes to the next available instance. If there is any sticky sessions are enabled, if they if the sticky sessions are enabled, we have to go to that sticky sessions, and we have to disable. Then only the traffic will go to two instances. It means it will balance the traffic, uh, and we have to check the health and response time of the instance. If one instance is slower to respond, ALB might send fewer requests there. That's why we have to check CPU, memory, and network usage of both EC2 instances, and application logs for delays. Like this, we have to check, and we have to check cross zone load balancing also. Means EC2 are in different availability zones, but cross zone load balancing is disabled. Then also we face the issue. It may prefer instances in the same availability zone as client. This can cause uneven distribution also. We have to fix this issue, like we have to go to that application load balancer attributes, and we have to enable the cross load balancing. This makes ALB send traffic evenly across all instances if instances in different availability zones also. And we have to check the connections and long-lived connections, like if clients open long-lived TCP connections, they may stay bound to one instance. ALB does not rebalance this mid connection. That's why we will face this issue. uh, like this, we have to check everything, then issue can be resolved.
Okay, very well explained, the Naresh. So the work of ALB is distributing the traffic equally. So if your one instance is not working or not healthy, then it will send the traffic to other instance. That is the one scenario. But for that also we can do troubleshooting, like we can have the auto scaling group also. But if your one instance is not working, in that case, auto scaling group will create a new instance, or we will create repair that instance, whatever the problem is there. That way also we can do. Other way, you very well explained in detailed way all the scenarios. We have to check the cross regional things. We have to enable in the settings. That things we have to do and check. All
Yeah.
the things perfectly fine according to the scenario. Yes, we will go ahead with the next question now.
Yeah.
Yes, Manoj.
Yeah, I'm going this scenario with Rupa. Hey, hi, Rupa.
Hi, Manoj.
Yeah. Here we are deploying one of our application. That application is a multi-regional application. Means we have more than 2-3 region. We deployed that application. Okay. In with ALB means, and also we configure ALB application load balancer for each region. Okay, but our Europe customer are saying the latency. They are not getting quick response with your our application, from our application. Okay, and they we need to configure latency based routing technique, and how to improve our performance. Okay, how you will achieve that here with your tech stack?
Yeah, so as already mentioned, if your application is hosted in two different regions, configuring the latency-based routing policy is a good option, along with Route 53, the option which is available with us in AWS. So we can configure in Route 53, we can create latency route policies for our domain name. So for example, we have www.ecomwebsite.com. So we can create that ALB DNS in US East one region, and also we can create this with the same domain name, the ALB DNS in UE East or West region. So this is one thing what we can do, and also we can attach the Route 53 health checks at each of the at each ALB endpoints. This is the second option which we can do. If U region fails, then the traffic gets directly automatically falls back to the US region or any other location which we would have configured with. And also we can make use of CloudWatch monitoring tools like CloudWatch for monitoring these matrices to measure and verify the traffics and if there are any latencies. Yes.
Yeah, very well covered, Rupa. And as you going with the approach like whatever you explained, right? Legacy based, latency based routing technique you are going to create. That is good one. And additional that one, what I am preferring, anyone is asking in this scenario, I just adding CloudFront. Okay, this I'm adding this CloudFront in front of ALB, application load balancer. So what it is giving some more features. Okay, it will doing more performance. Like whenever our customer hit our domain name or our DNS, first it will go directly to the CloudFront. Okay, from CloudFront it will go to back ALB to our cluster. Like this I will set up like high level, because what it happen, CloudFront, whenever one guy is coming, he is searching from some details or some sessions. Okay, first time CloudFront will come to backend and it will fetch the details and it will serve to our first customer. Okay, if the second time same guy is coming and searching same things, then it will not go backend our cluster. It just serve from the CloudFront, because CloudFront has the feature like cache, where it will store the details which we searched first time. Okay, in the second time if we get the same requirement, then it will directly serve from cache, even though it is a different person also. If he is reaching same CloudFront or same region, then it will serve from there. Like this we can give more optimizing the things, and also using from this, whatever we are doing, we increasing our latency based. Okay, because it is not going backend, you agree, right? So there is a step is reduced.
Yes.
Another one thing, like we reduce the cost, mainly cost. Because if you think like 1 million request you are getting for one video, like it is a trending, like you deploying one real time project and you hosted in YouTube, then every like million of people want to watch that. If you think all the request, if you is going to backend server, what it will happen? It will crash, right? Otherwise we need to increase the resource. Okay, if the same thing, same video, we will keep it in our CloudFront. If our request is coming and if we use that CloudFront cache resource and we are giving, then what it will happen? We most of the resource, whatever we need to do auto scaling, it will reduce. So like this, it will give the cost benefit also for us. Yeah, we can go. We can done with this concept, Sonali.
Yes. So thank you so much. Very well explained, Manoj, you
Yeah.
and Rupa. So if you have any question related to scenario based, or if you want career guidance, or if you are keep getting rejected in the interview, if you are, don't know where you are lagging, you want to identify your gap, feel free to reach out us to our experts or to me. So we would be happy to help you. So thank you so much. Thank you all.
Thank you.
Thank you all.
Thank you, Sonali. Thank you.
Thank you.